Welcome everyone. Today we're diving into the world of Embeddings, a powerful tool in machine learning that helps computers understand complex data like words, images, and even sentences. Imagine trying to explain the meaning of a word, a picture to a computer. How would you do it? Embeddings are like a secret language that translates this complex data into numbers, making it easier for machines to process. By the end of the session, you'll know how embeddings work, where they are used, and why they are so important. Let's get ahead. Let's start with the basics. Embeddings are like a simplified map of complex data. Imagine you have a map of a city with every single street and building. It's detailed but hard to use. Now imagine simplifying the map to show only the main roads and landmarks. That's what embeddings do. They take high-dimensional data like a detailed map and turn it into a lower-dimensional space, like a simplified map, while keeping the important relationship in fact. Analogy: think of embeddings as a way to group similar things together. For example, words like king and queen would be close to each other in the embedding space because they are related. Can you think of two words or objects that should be close together in an embedding space? Why? Now, let's talk about how embeddings work. They are created using machine learning algorithms that are trained on huge amounts of data. These algorithms learn to map similar data points closer together in the lower dimensional space. For example, if the algorithm sees the words cards and dog used in similar contexts, it will place them close to each other in the embedding space. Key point: embeddings capture semantic relationship, meaning they understand the meaning behind the data, not just the data itself. Visual aid: look at this diagram. It shows how words like king, queen, man, and woman are placed close to each other because they are related. One of the biggest advantages of embeddings is that they turn complex data into numbers. Why is this important? Because computers love numbers. They can process numbers much faster than text or images. If you want to understand the difference between a cat and a dog, you can represent both as numerical vectors. The computer can then compare these vectors to see how similar or different they are. Let's play a quick game. I'll give you two words, and you tell me if they should be close or far apart in the embedding space. Ready? One of the most common uses of embeddings is in natural language processing (NLP). For example, word embeddings. These represent words as vectors, capturing their meaning and relationships. Sentence embeddings. These represent entire sentence, helping machines understand context. Real-world example: Google Translate use embeddings to understand the meaning of words and sentences in different languages. Another school application is in recommendation systems like Netflix or Spotify. Here's how it works. 1. User embeddings represent users based on their preferences. 2. Item embeddings represent products like movies or songs based on their features. 3. Recommendation engine, such as products similar to what the user has liked before. Fun fact: Netflix use embeddings to recommend movies you might like based on what you've watched before. That's why you keep finding new shows to binge. Why are embeddings so powerful? Here are 3 key advantages. 1. Improves accuracy. They picture semantic relationships, making machine learning tasks more accurate. 2. Efficiency. They simplify complex data, making it easier for computers to process. 3. Scalability. They can handle huge datasets and complex models. Let's look at some real-world examples. One Netflix use Embeddings to recommend movies. 2. Google Photos use Embeddings for image research. 3. Chatbots use Embeddings to understand and respond to customer queries. To wrap up, embeddings are a fundamental building block of modern machine learning. They help bridge the gap between human understanding and computer processing, unlocking insights from vast amounts of data, whether it's recommending movies, translating languages, or recognizing images. Embeddings are revolutionizing how we interact with technology.